Hello everyone, welcome to the Learning Objective 3 Exercise 3. We're going to talk about using dummy variables in regression. As always, you can download this file from our website and it consists of three tabs. First is exercise, where we're going to do the calculation step by step. Then there is the exercise solution, where the solution is already prepared for you. And there is also a question tab, where you have a new data set and you have to do a similar calculation, but the solution will be provided for you only after you upload the solution to our website. So let's get to it. You are a real estate analyst and you would like to find out a relationship between price of a properties and its size. You have collected the data below, which you can see over here, for two city parts, part A and part B, and you know that prices in part A are higher as it is considered a better neighborhood due to its higher quality school, so you would like to factor the location into your analysis. And you have to calculate a regression using a dummy variable. Well, why dummies? Because the city part, which is signified in here in the data set as A or B, is a categorical variable. So you have to first kind of transform it into numbers, and only then you can calculate the regression. So each line is one property. For each property, you have a price, which is for our purpose uh, independent variable, the one for which we look into relationship for, and then you have a also the where is it located, either in a city part A or B, or square feet, also square feet, which is the size of the property. So how to how to calculate the regression. So first, we have to transform the categorical data in numerical data. For dummies, you basically use only one or two or zero as two default numbers for each categories. In this case, it's quite easy because we have only like one category with only two possible options, A and B. So one city part will be A and one city part is going to be B. It doesn't really matter which one is one, for which city part we're going to assign one and zero. The equation, of course, at the end is a little bit different, but the relationship is still the same. Only the city part to for which we're going to assign zero is going to be swallowed by the intercept. So and I'm going to show you how it works after we get there. So first, we basically want to assign ones to city part A and B's to the city part B, which you could think it's probably the easiest thing to do, right? You just copy it in. We have it nicely sorted, so we don't have to even have to look for it. But sometimes you have a much longer data sets, and it's much more difficult to actually do it without any mistakes if you do it cell by cell. So I will show you how to use VLOOKUP function to actually do it automatically. So first, the dummy variable, we define a range. So A is going to be 1 and B's are going to be 0. And then we use the VLOOKUP function. VLOOKUP, and again, very nicely, it shows what the formula actually wants. So the VLOOKUP, the lookup value will be always the individual cell. So this cell over here, then it wants the table array. Well, we just prepared it here, so I have to kind of move behind the formula over here. Just by moving and pressing shift down, I highlight the four cells which I actually want to highlight. Call index number. So there's two options. So we actually want to put there 2. And now, is it approximate match or exact match? Well, it's only A and B, so it's exact. And indeed, it identified one for A. And now I just have to copy it down. Control C, Control V. And of course, I made a little mistake, and I know exactly where. If I press on the formula, this part, this range which I prepared before, I don't want it to change. So I'm going to highlight just this part of the formula and press F4, that locks it. And now I'm just going to highlight it once again, Control C, sorry, I already pressed Control C before, I have it pressed, so just highlight, Control V, and indeed it does what I wanted to do. So A's are 1, B's are 0. Again, in this dataset it doesn't make much sense to use the VLOOKUP function, but sometimes you have datasets which are thousands and thousands of rows long, and then it's really handy. So we have a independent variable price and two dependent variables. We're going to use the data analysis tool. So we go data analysis tool. If it's not there for you, you go to options, try to show you quickly so it's not too repetitive, add-ins, go press analysis tool pack. So data analysis, you choose regression, okay. Y range, starting with the data label, you always want the data label in there. Control Shift down arrow highlights the whole column. X range, so we want to use square feet and the dummy variable. So I highlight both of the cells above here. Then Control Shift down arrow highlights the whole data set in the columns I need. Choose labels. If you don't choose the labels, it will think that the label over here is yet another data point, and it will show up error because it's not numerical. So always click in the label, output range over here, and we want to click residual and residual plots because we're going to examine them in a second, and press OK. Regression. Well, regression is quite strong. R square is 0.85, which is quite good. And that these are the individual slopes. So this is the intercept and two slopes for each. Oh, see, there's a surprising thing. The city A is actually not cheaper. It's actually more expensive. I wonder how that happened. Maybe it just appeared that way because the properties in that city part are bigger. So we already proved that the expectation which we had over here is not true. Because for every property located in city part A, you actually get a discount because this number is negative. Anyway, let's go to the residual plots. And if we look at the dummy variable, they always are zeros or ones, so they are all clustered around. Uh, they are nicely clustered above and below. There doesn't seem to be any systematic errors, so it's fine. So we don't have to do anything with the dummy variable. But look at the square feet residual plot. There is definitely a systematic error. It goes like from under and below. Just shows somehow a systematic error that there's definitely a better line than the linear regression which we have used before. So what does that mean? If you see a systematic error like this, it probably means that quadratic equation would probably serve better than just a linear regression. It could also be a logarithmic. If it's literally round, like in this case, it's probably quadratic. And if it's kind of like shaped more like a little roof, it's more logarithmic. But in this case, I would probably guess quadratic. You can, if you do correlations and regression analysis, it's it's a good idea to kind of play around it and kind of try fit the different lines. So you like eventually, and you always watch the R square, multiple the R square, and you basically look for regression which has this number over here the highest. So we want to use a little bit more complicated regression line as a regression analysis. So how will we do it? Well, the square feet here is represented as a normal variable. So I'm going to insert another column over here. I'm going to call it square feet squared. It sounds kind of funny, but that's what it is. And I'm going to take the numbers from the square feet and I'm going to square them. Again, I'm going to copy the formula down. So each of the data points is the square of the cell to the left. And now I'm going to delete this residual output over here, so I make space. And I'm going to do the same calculation once more. So data analysis, regression, okay. The Y range is still correct, so I can just leave it. The X range I have to change because we have now one more variable. We have also the square feet squared. Output range, I want it over here, just under the previous table. Residual plots and residuals. And here we are. So like almost immediately we can see that the R square in this second regression is bigger than from the one which we did before. So the regression is actually better fitting than it was before. Where are our residual plots? They are over here. City dummy is still alright as it was before. And instead of, they are kind of confusing now because they are covering with the other ones. I'll probably delete them all and generate them once more to make it clear. So it will take only a second. Everything is already set up. I'll just confirm this. Yes, I have no problem with overriding. I just know that this thing shouldn't be here. And the residual plots are over here. And so the city part dummies are still alright. You know, they are nicely clustered above and below. But also square feet residual plot and square feet squared residual plots are now much more. It doesn't show the systematic error as it showed before because we included the squaring of the size of the property, which removed that systematic error from it. So now I can just take these numbers and create the equation which we are looking for. So y, or the price of the property, equals 7573. I'm going to round so I don't have to write so much. Plus 258x, or square feet. I can use just the apartment size, minus 0.03 apartment size squared, minus 123803 city part. You can also, of course, write this equation a little bit differently as well. I'm just going to copy it, and you can just write x1 minus x1. And now in this in Excel, it's kind of hard to use um, the squaring, so it will be x1 squared, and this could be x2. So this is the equation of the relationship of how much the individual properties cost and how the price is derived. So basically, intercept is 7573 plus the area is represented by these two, the x1 and x1 squared. So with size, the property prices are getting a little bit cheaper, just a little bit, because if you look at 0.03, it's not really so much of an impact, is it? But if I actually want to see if the relationship is reasonably strong, I look at the confidence intervals, even for the for the 95 certainty, 95% confidence interval, we can see that it doesn't go over zero, which is good because it means that at 95% significance, the relationship exists. So that's the end of our calculation. So thank you very much for your attention. After you complete this practice calculation, go to the question tab, and there's another exercise waiting for you, which you're supposed to complete by yourself and upload it to our website. So once again, thank you very much, and see you next video.